Hello everyone, my name is Mary Wildner and I decided to explore the biophysics of swimming. The purpose of my lab was to calculate the contact force with which a swimmer, my friend Will, pushes off a block at each position point from a video I extracted with Tracker. Then, just for funsies, I wanted to graph the change in the forces present and the energies and work present. To do so, I needed Newton's second law, knowing that the change in momentum over change in time equals the summation of all forces present. And then also I used the energy principle, which states that the total change in energy within a system equals the work from the surroundings. With my setup, I'm viewing Will as a real system, and the surroundings consist of the Earth and the starting block. So the only forces present are the force of gravity and the contact force. I assumed air resistance would be negligible because although Will is a very fast swimmer, his dive is still at a relatively low speed. So here you can see my video of Will diving off the block. When making my center of mass position points, I tried to keep them at relatively the exact same position on his body, so where his white skin meets his black jammers was a pretty easy point to keep hitting every time. And while I'm setting this up, again, my main goal is to find the net force by viewing it as the change in momentum over change in time. And then here is a graph of the contact force, and to find the contact force, I just subtracted the force of gravity from the change in momentum over change in time. So you can see how the contact force is a little all over the place. So that means that Will is actually fastest at this peak right here versus when he's leaving the block, so his dive is not very efficient. And then here's a graph of the different works present. So first I have the change in kinetic energy, change in gravitational potential energy. Well, actually in this case this is the work from the Earth, and I have his change in internal energy and the work from the block. And the work from the block is just the dot product of the contact force and the position vector of which the contact force is being applied, so his entire time frame on the block, how his position changes while he's on the block, that would be the position vector that I would use with the contact force to then find the work from the block. So first I needed to extract my position data from Tracker and Python, so I just used this handy dandy while loop. And then I used Newton's second law and 3 points at a time from Tracker to update Will's change in momentum over change in time, so thus I was able to have a net force at every 3 position points. So first you need 2 position points just to have a velocity, and then you add in another position point to have a change in velocity over change in time, and then by multiplying that by the mass, then you have your change in momentum over change in time. And coding the contact force, I just subtracted the force of gravity from the net force, so the dp dt that I had just calculated. And coding the energies present and the works present, I just used the standard change in kinetic energy formula, and the work from the Earth, standard equation. Work from the block, again, is just the dot product between the contact force and the position vector. And whatever's left over is going to be the change in internal energy, because we know that all the energies within the system have to equal all the works from the surroundings. So if I just want one of the energy changes, then I have my total work from the surrounding minus the other energy present within the system. So again, here's my graph of the contact force. The force of gravity is relatively constant the entire time because Will's Y position does not change hardly at all while he's on the block. So what's really changing is his velocity while he's on the block. So he peaks in the middle of his dive versus peaking at the end of pushing off the block, showing that his dive is not very efficient. Ideally, his peak would be at the very end so that he can enter the water with as much speed as possible. And then here, again, I have the graph of the different works present and the energy changes. So the work from the Earth is relatively constant the entire time because, again, his Y position is hardly changing. And here, the green line is the work from the block, which is a little up and down because the contact force is also a little up and down. So I hope y'all enjoyed my lab, and thank you for watching my video.